Okay, so we're going to do examples 6 and 7 in this video. And the first thing we're going to look for is the vertical asymptote. So we just have to set x minus 2 equal to 0. And that tells us that the vertical asymptote is x equals 2. So I'm going to come over to 2, and I'm going to go ahead and draw in that vertical asymptote. Put arrows on both sides. We also have, apparently, we're going to have an oblique asymptote because the degree of the numerator, which is 2, is bigger than the degree of the denominator, which is 1. So to find that, you're going to have to do a little synthetic division. You take that vertical asymptote number, which is 2, because that's what you, when you're doing synthetic, you set that equal to 0, and you place positive 2 in there. You have x squared, you have 0x, and you have plus 1. There is no x in the middle, so it's 0x. So your coefficients are 1, 0, and 1. And we'll draw a line, do a little synthetic division here, bring down the 1. 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 1 plus 4 is 5. According to the rules, you ignore the remainder. No matter what it is, you ignore it. And you just take and you set the quotient, which is x plus 2, equal to y. So we have to graph this. What this means is your y-intercept is 2 and your slope is 1. So if the y-intercept is 2, that's right here. And 1 means that you are counting up 1 and over 1. Now remember, we're not drawing the graph right here. We're only drawing an asymptote. This is what the graph will not cross, okay? So this is going to be a little tricky for me. So let me come in here because I'm doing this with my little wireless board. So, oops. Let me that back one more time. I'm going to come in here and grab this guy, and I may have to fix him just a hair. But let me pull this guy in all the way to here, and actually it looks pretty good. Okay, I'm going to keep that just like that because he is dotted on there. Now, I will go ahead and change to a color that we don't have up here, and how about we do purple? For the rest of this, we're going to find the points necessary to draw the graph. For instance, again, x-intercepts and y-intercepts, those are not mandatory. But if you're going to find an x-intercept, you have to let y be 0. And that means that you're going to put 0 right here and say 0 equals x squared plus 1 and divide that by x minus 2. And when you cross multiply, 0 times x minus 2 is 0, but x squared plus 1, subtract 1, and look at that. When you square root this, you get an imaginary answer. Square root of negative 1. That means at this point, at this answer, you have no solution, which means you have no x-intercepts. Okay, it never actually crosses this x-axis at all. And how about the y-intercepts? You got to let x be 0, so that would be 0 squared plus 1 divided by 0 minus 2, and that would be left with 1 divided by negative 2, which is negative 1/2, which puts us right about here. And remember, it never crosses this axis right here, so we got to keep that in mind. It's below, okay? It's going to be below this axis in that little section there. All right, does it cross the oblique, okay? You can set up and solve an equation like this, but you most likely will not have to do that. And I'm not going to require that you figure out if it crosses the oblique. We're just going to pick points. We're going to pick enough points that it's going to go through, and we're going to be able to figure this out. So I'm going to go ahead and make an XY chart again. And let me get back to my normal little vertical line here. Okay, and let's pick some points by section. First of all, again, the end is negative 12, and we're going to keep going over. Do not stop here. Keep going all the way until you get to the vertical asymptote. So at the very end, let's pick negative 12. Let's pick somewhere in the middle of this blue in the end, you know, negative 5, negative 6. Really doesn't matter. And how about somewhere really close to the asymptote, like 1.9? I think I forgot to write it up here. I said negative 6. And then oops, that's what I did. Hold on one second. Let me back that up there. I put negative 5 on the wrong side. I knew it was there somewhere. So we got negative 5, and then we said right up to this asymptote, positive 1.9. we're going to check that out. So let me go to the handy dandy calculator. You're going to be doing it on your scientific calculator. You will not be allowed a graphing calculator. So we got negative 12, and that is at negative 10.4. So at negative 12, we're down here at negative 10, which is right here. 0.4 puts us right here. It's up right against the asymptotes. We have negative 5, and that is at negative 3.7. At negative 5, negative 1, 2, 3.7 puts us up against the oblique asymptote. Let's check out 1.9, because we know it's not going up, just because we know it doesn't cross here because there was no x-intercept. But let's check out 1.9 really quick. And that turns out to be negative 46. That's huge. Huge as in very small, because it's going way down the asymptote. So we're going to go ahead and sketch this in, because we have a point up there which was our y-intercept. We're just going to go up to this point. We're going to turn it. We're going to come down. That is enough to make a sketch of the graph. Now, if you did not have this point right here, which is our y-intercept, pick 1, pick 0, pick a point in there that makes it more accurate, okay? But that is this section of the graph. Now we're going to go to the other side of the graph, which would be just to the right of the asymptote, is about 2.1. Somewhere in the middle of this section right here, let's start it. Let's do 7. And the very end, let's do 12. And let's check these points out. At 2.1, we are at 54. Huge number, huge number. So what that tells me is that we are way up here somewhere. Okay, we're way up there somewhere. I might choose another number because there might not be enough points to actually tell whether or not where to draw this at. But let's try 7. 7 is at 10. So when we're at 7 right here, we're all the way up here at 10. When we're at 12, I'm going to tell you 12 is probably not the best number to pick, because it's all the way over here and it's going to be up here off the graph somewhere. But it turns out to be 14.5. Now we don't have a lot of points in here, so let me pick one that maybe gets down here in the corner. 4. Sometimes you have to make adjustments. Let's see, 4 turns out to be about 8.5. I can graph that one for sure. 4 up 8.5 puts us here. And we already know it goes up the asymptote, so it is enough just to draw this. But I'm going to check out 3 just to be sure. 3 actually turns out to be 10, because like I said, you have to make adjustments sometimes. So here's 310. So you can see that this graph is curving through here, and it follows the oblique asymptote. No V's, okay? Curve it. Make sure it's not a V. You don't have a point there at the bottom. And that completes the graph of example number 6. All right, so the last one, example number 7. One thing that you're going to have to look for on every single problem that you do, and I know it's going to be hard for you because some of us have a hard time recognizing factoring, but x squared minus 4, that is the difference of perfect squares. You can actually factor that into x plus 2 times x minus 2 all over x minus 2. Why you would want to do that, or why you have to do that, is because if you can reduce a fraction before you start, then you have to. Okay, you have to reduce before you start. So here's the thing. From the very beginning, the number 2 is still a bad number. If I said, oh, let's find a vertical asymptote to this. Well, x minus 2 equals 0, x equals 2. Technically, it's not a vertical asymptote, but it's still a bad number in the graph. The only graph left after reducing is y equals x plus 2. That's the only thing left to graph. But we have to remember this is a bad number. So this is just a linear graph. It has a y-intercept of 2. It has a slope of 1, up 1 over 1. But the thing I have to be aware of is that technically there is no answer at 2. At 2, there's no answer. We don't call it an asymptote because the graph does not turn and follow it, okay? It just skips over it. There's a hole in the graph itself. So I'm going to come up here and grab a nice straight line with arrows. I would just grab this one here, and I'll put my own arrows on. But we got to draw a nice line through here. And you know what? I'm going to redo that because my little board is going to be very hard to draw. I'm going to go and come up here and I'm going to kind of freehand this because we need to draw this in a way, and let me draw it with the blue here. We need to draw this in a way that when we get to this little hole, it just kind of skips over it. Once you get that drawn, you put your arrows on both sides and that graph is complete. So here's the thing, steps. You notice if it factors, okay? You notice if it factors. If it does, you factor it and you cancel whatever you can to reduce the fraction. What's left is what you graph. But you still have to take in consideration that the number 2, which in this case is, not in the domain of f of x, is a bad number. If I go back to the previous one, x squared plus 1, we do not have a rule for the sum of squares. There is no factoring that can be done. If I go back to this one, these are both linear. There's no factoring that can be done. There's no even greatest common factor. And back to example number 4. This one down here, we factored already. We took care of that, but you couldn't factor in the numerator, and therefore there was nothing to cancel at all. So that completes example 6 and 7. Hope that helps.